So in this video, I'm going to work on audio a little bit, and looking at my board, just as a reminder, the bottom half of this, as it comes apart, is my primary board. The top half is my audio visual board. And I've been doing a bit with VGA recently on the VGA output. I haven't done much on the audio side yet. So I wanted to get audio access working from my C shell down here on the primary board. And that's what I've done. And I'm going to walk through kind of what that looks like here as we go through this. So as I look at this up here, what I would call out is that, it's another 65265. And there is a via here and a pair of YM2149 programmable sound generators. So this via controls those two sound generators. And like with many of the videos in the past of this series, from my primary board, I want the shell that I write in C to call the operating system on this board, and for it to make a PIB call, or a parallel interface bus call, over to this other board, and it will then do all of the sound control. And I have my system booted up, and I'm going to pull my mouse and this little NES gamepad off to the side for now. And just to show you a couple of things, if I now type help, I've added shooter and win. Those were there before. So my little windows and the little shooter where I could move the gamepad. Those were just simple little test apps to test these two input devices. But I now have a play music and a play sound effects and a shooter too, which I'll show you before I'm done. So the way that it works with play music is I can type play music and give it an ID of music that's stored just in my ROM on my secondary board. And so I'll do a play music, and I am trying to record the audio separately here, so my main mic will probably mute it or filter it out because of noise cancellation, but I'm recording it separately. So in editing, I'll try to insert that over the exact spot here. So hopefully this will come through okay. But I can say play music, and then I can just give it a hex ID, and I'll say play music 2 here. Okay, that was probably terribly annoying music or sound that made. And you're going to hear some worse music here as we go. I've just simply asked AI to generate, and I gave it some suggestions of the songs, and its interpretation or implementation is pretty bad. But I'll show you that here in a little bit. But that was just a song that it could play. Now I'll play another one. I'll play music. And I'll do the very first song, which is 0. And it's a little bit of a Mario. And at the beginning, that's what it sounds like, but then it falls off the rails pretty quickly. So isn't that lovely? Anyways, it's playing music though. And I could come in here and I could say play music, whatever I've got for other options. 1. Now what you're noticing as I'm going through and doing this, I'm just saying, oops, play music and giving it a hex ID. And that one must not have anything good in it. Play music C. And so some of these, if you go back to my older videos with audio, you might recognize some of these intros. I was at some point just given it some of my existing song data to Gemini and asking it to put it into this new format I'm using, and it only can do a little bit of it because it just doesn't let me upload enough of it. But also, as I was going through here, some of this, as I was doing a play music, it was probably around 4. That sounds more like a sound effect, and actually playing music is very similar to sound effects, but I can do that. So I can play whatever I want to come up and play, but basically what I'm using is I have 2 PSGs. Each of these has 3 channels or voices, I think some people will call it. So I've got 6 channels or 6 voices that I can work with. And in general, what I'm going to try to do is have 4 of them be used for music type of tones, and 2 of them be used for sound effects. Now, in addition to this, I have, going back to help, I can do a play sound effects, and I can say sound effects 0, play sound effects 1, play sound effects 2, play sound effects 3. That one must not be working. I probably have some work to do there. 4, and I don't remember how far I went. And if I pick a non-existent one, it's probably not going to be good. Okay, and that one didn't work, didn't do anything. So maybe play sound effects 4. So that's an example of a sound effect. Now, in addition to this, I can do both at the same time. So I could say play music 2, and as soon as I get this running, I'm going to have it play sound effect number 4. And I'll just use that one as an example, or number 2. But you get the point there. I'm doing both concurrently. So I can play, 4 channels of music, and on top of it, concurrently, I can play sound effects with 2 channels. And at the same time, this board is doing all of my video output. So if I go back, I'm just going to get out of this. Oops, I told it to play something that I shouldn't have, DDD. But I'm going to go ahead. Oh, and it's finding something there. Let's play music. Let's go back to 0. Okay, so what happened there is I told it to play music at a certain number, and probably in my code it jumped to some address that really isn't music, messed up some of the audio registers, and then as it got to the end, I shut them all off. So it should be back to normal now if I do a play music 0. Oh, that sounds so bad. But I'm not worried about the content of the music, so that's all something I can take lots of time later. And I'll talk about song or music creation later. I actually have some tooling for that that I just need to put some time into building some music. But I can play music, I can play sound effects at the same time, and I can do all the graphics work. So I'm going to start another one of these musics, and then I'm going to, while I'm doing that, run my graphics test at the same time, because all of that is being processed on this board. So I can do a play music, and I'll play music 2, and then as soon as that's running, I will go ahead and continue. You'll notice that I can, for my OS, keep on, or for my shell on my OS, keep on running, doing other things while this is processing. But I'm going to do a play music 2. Okay. So what was happening there is this board is playing audio as the music, basically, and then on top of that, it's doing all of the video output. So it's doing quite a bit. And how do I make all that happen, plus leave the user open to type and do other things down on the primary board here? Well, that's part of maybe how this architecture is starting to come together pretty well. From my shell, I do this coprocessor call to the OS, and the OS makes a PIB call to the other board. But it can just simply submit the command and then continue doing other things. So at that point, this board says, okay, I've told you to play a music piece, and it returns and starts doing whatever the next thing is it wants to do. Then this board up here will now work on processing that. Well, that doesn't sound so bad, but if that's processing that, and then I come through and I say draw a rectangle or draw a sprite or clear the screen, this board has to do that simultaneously. Now, of course, it can't do two things at one time. This isn't like a multi-core, multi-threaded type of processor. But what I can do, though, is have all of the music be handled through interrupts. And that's what I'm doing. I'm running all of the music and the sound effects through basically an interrupt from a timer. And I'm using a timer built into the VIA. So the VIA, I configure a timer. And basically, I just send it a command of, I want you to play this music, or I want you to play this sound effect. And that timer fires many times per second and basically plays the next note if it's ready for the next note, or it waits if it needs to wait. So it's reading through my music data and then playing or setting the outputs of these PSGs accordingly based on however I created the music, and it's reading through that data. So that gives me the ability for this audio all to run off of interrupts, meaning I can make a call and have it do my graphics work, not in an interrupt, but in a routine that just simply runs through and does the draw rectangle or whatever it is. But as it's doing that, it'll get interrupted to flip to the next notes as needed. And that's all working fairly well. Every once in a while, I'll see a little bit of a graphical glitch, but you can watch as we go through this and see if you catch any. But it seems to be pretty decent. So now to further test that, then I put together, I took this first shooter from the last video where I was just using that to move a little crosshair around and draw on the screen. But I created a shooter 2. And when I run this right away, it's going to play some music. But watch as it's, basically playing music. I'm going to move around and press buttons, and you're going to see it's going to draw when I press the buttons. Plus, it's going to play sound effects at the same time. So what you're seeing here is I was playing and playing. Okay, so what's happening there is that song had a pause in the middle of it, but that song was playing. As it's playing, I can move the controller and see my crosshair move around. The left button draws a diamond, the right button draws a circle, and then I just tied a sound effect to each of them. And then I can click once and hold and draw. I don't have it repeat the sound effects, but I can get my lines that way. I can do the double and get my squares. And I can hit start and it'll basically go to the next song. And a lot of the songs I have right now are kind of, well, they're almost all kind of garbage. But again, that's not the point. I'm just trying to play some tunes here. And what I'm playing right now is nowhere near what this is capable of doing as far as quality. So if any of you are interested, look up, I have an older video on PSGs, and I play through some songs that go up to, I think, 6 channels on a Mario 1-up. And that sounds pretty good in my opinion. But if I press start here, it's going to clear my screen and rotate to the next song. So that's what it did, is it played that little piece of music, and while it was doing that, I was continuing to use the system. I can go to song number 4, and actually I don't have a song 4, that's sound effects, so it jumped up to song number 9. That's the next entry I have, and then I'll go 10 through some number before it wraps back to 0. So there's enough annoying music. But what you're seeing now, I can hit the select and get back out of that program. But I have added in support for command line to play music, play a sound effect, run the shooter that's basically doing music plus sound effects plus game controller input plus all the graphics drawing all simultaneously. And that is probably the best I've ever had a 65/816 type of processor, or in this case, of course, a 265, running all of that stuff at once, and it's honestly pretty smooth. So if I start a song again, I'll run the graphics test again just one more time to see how it performs here. But I'll do a play music. I'll do 2, and then I will do the graphics test. And so there I see one pixel that looks like it didn't draw correctly. Okay, so that's enough hurting your ears with that terrible music. Let me show you what it takes to put all this together. And I'm going to go over to my code. And I have my C shell down in this source folder. And in that shell, I've added the appropriate cop calls so that I can, from my operating system now, call an OS play music or an OS play sound effects. And if I go look at what is in those, it's just making a cop call. So I'm telling it, here's where I want some parameter data stored that the OS can get to. Call cop21, hex 21, which is play music. Cop22 is play sound effects. And then I have put together, the little shooter 2, which basically reads the NES gamepad, it draws, it plays sound effects, it plays music, all of that. The code is just this block right here, what I was showing you. Now it's leveraging all kinds of routines that I have over in my OS for basically making cop calls to my operating system, to the processor down here. Well, that processor then is going to turn around and receive those as a cop call. And I'm now up to this list of cop calls, so the list is growing. But here's my play music, play sound effects, and when I come down here, you can see that I have routines that basically just call a PIB call, and that is a PIB master or primary that is going to talk to the secondary board. And so that's all the PIB these routines will do, is basically say, I want to run a certain command, pass that number over to the other board after it has some variables in memory that the other board can access. So in this case, I'm going to go ahead and send the command that I want to do this right here. Now, before it got to that in the cop call, just so I can point this out, it does copy memory that my C application wrote those parameters to, and it copies it to a space that my other board has access to, which is a dual port static RAM on this board that both processors, both microcontrollers, have access to. So then the other board receives the PIB call as a slave, and then it has routines that basically say, okay, you want to play music, let me go look up the parameter at a certain address that you said you want to play for the ID of the music or the ID of the sound effects. It then looks up where the data is for that entry, and then basically goes and calls a routine called start music or a routine called start sound effects. And I'm putting all of those into this assembly file called sound. So if you come in here, there is this assembly file, and let me collapse everything. But basically in this, I've got it set up to support my 10 megahertz Phi2 clock with a pair of these YM2149 PSGs. You could also use the AY389 series. That would be fine. They're basically drop-in comparable ICs. And then this has basically two things it can do. It can do this background music type of playback, and it has its little engine for that. And then there's a sound effects engine. And this background music uses 4 of the channels. The sound effects uses 2 of the other channels. So I'm using up all 6 there. And if I want, the background music could use all 6, but I'm trying not to, so that when I play sound effects, it doesn't trash the music that is trying to play at the same time. But if I had like some intro music to a game or something and I wanted all 6 channels, I could do that. Now in here, then I have initialization code, and I have to, of course, initialize like the VIA itself, and then I have to work with the registers on these programmable sound generators. And again, I've got an old video that goes through these PSGs in detail. So if you're interested in how to program those, look for that. I'll put a link in the YouTube comments to that older set of content. But basically, you choose registers that tell it, what is the frequency of the tone, or what tone do you want to play, or if you want to generate noise, you can start creating sound effects. And you can combine things. You can set different envelopes for effects. There's quite a bit you can do with these PSGs. So that just gets it set up, and sets some initial values to it. So I go out and I say, well, I need to write out to a certain register, a certain value to, like, for example, here, this register 8, 9, and 10. That lets me basically set volume. So I can come in here and I can say, well, I'll set the volume to the max right away. But I can turn down the volume as it plays back. I can silence them. I can disable things, etc. But after that, then I have this audio ISR. Now, the way I've set these up is I am using a timer on this VIA, and here you can see where I actually set up that timer. So I come in here and I tell this VIA that I want to do what's called a continuous timer interrupt, and then I tell it that I want to enable that interrupt, and I give it the kind of the duration, how long between interrupts. So the timer just counts down essentially, and after it counts through this number, a high and low byte, it triggers the timer. And the way I have this set up right now, I'm using C2A2, and I think that gives me about an 88 hertz if I'm using that with my 10 megahertz Phi2. And this is all stuff I've got to dial in. So how long between those interrupts, and probably the higher the number, the less maybe effort it is on the system. It's not constantly hitting that interrupt. But also the downside then is I probably don't get as much granularity in my playback of sound effects and things like that. I want it to be a faster hit on the interrupt so that I can more rapidly change, like gradual increases, decreases of sound effects, volume, things like that. But this is going to set up an interrupt, and when I come into my system, I can go up to the main file for the AV board, and way down in the interrupt handlers, I have interrupt handler for IRQB. So this VIA has an output that is labeled IRQB, and I have that tied to my processor IRQB, so it can pull the IRQ for the processor. And I actually run it through a chip that aggregates up to 8 different sources of interrupts, but then brings it over to IRQB. And then in that interrupt, I come in here and I just have to, check where was my interrupt coming from. And if it was coming from, this specific VIA, this specific timer, then I want it to basically jump over to this audio interrupt service routine. And so that was back in the previous file, this sound, and I have audio. And this is what gets called on that heartbeat. And so whatever it is, let's say it's at 80 hertz, 80 times a second. Basically, it's going to come in here, and then I'm going to have to do some work to actually play music or play sound effects. Now, I wanted to go a little bit slower inside of this. 80 was a little bit faster. I wouldn't mind trying to get to 60 specifically, so I'll work on that later. But this just simply slows it down. It just says, hey, only look at really every 4 interrupts. So ignore 3 of them and don't do this work unless it's every 4th. But then I check, is this music flag active? And that would have been set on the incoming PIB type of call. Also check if there's a sound effect that I need to do something with. But then it's got the functionality down here that basically steps through music data. So it'll say, okay, for this current point in time, start playing these tones or these notes. And then maybe it goes through a whole bunch of cycles where it doesn't change anything because it's holding the note. But then at some point it's going to say, oh, now you need to play the next note in the tune. But all that logic is built in here. And you can go through this. This is way different than I've ever done it before. All the audio stuff I've done up to this point has always been just, it's me doing timer, or not timers, but delays, like little loops for delays and things like that. I haven't used timers for audio. And in this case, I am using this timer on the VIA to generate an interrupt. And that interrupt then has to look up music data, which I've got a bunch of music data over here in this ROM. For example, if I collapse this, maybe that first one was this really bad Mario song. But in that, basically, I'm saying I want you to do certain things. And for the most part, it's here is a register number 7, and I want you to set it to 38. And then I want you to go to register 17 and set it to 38. Now what this 38 does, I'd go to the data sheet for the PSG, but it says for register 7, I have 8 bits that I can set. I can turn on tones, turn off tones, or turn on noise and turn off noise. But I'm setting it with this bit pattern, and that tells it turn on tones and turn off noise. In other words, I want to play music, not sound effects. And that's for PSG 0. And then I say go to PSG 1. Now, these PSGs don't have hex 17. They don't have that many registers. But basically, the way I've done this is if I append a 1, that tells it it's the second PSG. It's PSG 1. So basically, the first number in the hex is which PSG am I working with. The second is which register number 0 to 15. And then what value do I want to set it to. And so if it contains this 1 here, when I actually read this data, I'll have to process it and say, oh, do that on the second PSG instead of on the first PSG, or PSG 1 instead of PSG 2, or 0, sorry. But then this just goes through and says, okay, now go to this whatever register for a tone, set it to this specific frequency, or set the volume, or do something else. And you can see in some of these, I've also got some weights, wait a certain amount of time. But this is essentially, data that is, I can go out to AI and ask it to generate me some data, or better yet, I have software I've previously written that will generate me quality, like up to, well, however many channels. The most I support is 18 channels on one of my boards. So 18, let's see, six PSGs, so 18 channels. But it allows me to enter in very detailed music data, and it'll generate everything that I can play back dynamically. So I'm going to update that program to generate in this new interrupt-based format, so I can just go in, open up an existing song that I previously built, like this Mario 1-Up, and then have it generate it in this format, paste it into here, and then this should be able to play back with similar quality as I've done in the past. Now, sound effects are really no different. It's for example, here's a coin sound effect. So this sound effect just says set channel A on the first PSG to maximum of 15. And then I want to play a note 1, or a B5 is the note. I want to wait for 5 ticks. And then I want to play note 2, which is an E6, wait for 21 ticks. And then I want to turn off that channel or silence it. And then I designate I'm done with the sound effect with an FF. Just like up here, I designate I'm done with the music with an FF. And before the FF, I turn down all the volumes for all 6 channels. And I got a whole bunch of cleanup there because I think even as I go from one music file to another, it should be turning off all of the channels, but it seems like sometimes I hear carryover, but I'll have to, that might just be in the song itself that it sounds like it, but it's not really doing that. So I've got music data in here that I've been mostly just going to AI saying, okay, generate in this format, pick a song and do that. And it doesn't do very well with the song data. Some of the lower stuff, I told it to take some of my existing song data, which I have in a program I wrote, and I use XML to track all of the song data, and then I can output ROM binary. But I told it to convert the XML into this format I'm using in this app, and it seems to do okay, but it will only do about a second worth of it, 2 seconds, and then it says, well, that's the most I can process for you. So I'll need to find a different AI tool, or, like I said, update my little utility that can generate that. But then all these supporting, audio functions are inside of this sound. And again, you can look through it. The main ones really, though, is there's a start music and there's a start sound effect. And when I call start music, I need to say what's really the address of the music. So what's the address? This would be 2 bytes, and then what bank is it in? So you set your A, you set your X, you call this or jump to it, and it'll basically play that and return. And same with the sound effect. It's identical. It's just I'm trying to limit this to 2 of the channels. There is stuff like a music table. So this is just a table saying, here's all the different music. So if I say play music ID 0, it's going to go to Music Mario theme in bank 0. Or go to Music Zelda theme in bank 0. All of the stuff right now is in bank 0. It's in my smaller flash memory. Sound effects table, same thing. So those are the sound effects that I currently have set up. And then I have little sequences that do a reset. So basically go through all the registers and set these values. And you can see that we've got channel A, there's a tone period, fine and coarse. In other words, you have 2 bytes to set the frequency for channel A, 2 for channel B, channel C. If you want to get into sound effects, there's this noise period. There's this enable where you can enable channels, or these actually have I/O. So I have all of these open headers down here. Each of these PSGs has 16 bits of I/O, kind of like a VIA. So I can hook up more memory to them. I can hook up keypads, joysticks. They're just I/O. I can use them as GPIO. I just have to access them from my microcontroller to the VIA to the PSG to those GPIO. So it's a lot of overhead to use them, unless I've got a good reason to. Like maybe I could hook up a flash memory directly to one of these. And I've done that in the past. I hooked up a large flash memory right into one of the PSGs so it could access all of its music data directly right there. This board, I'm not going to do that because I already have a primary flash, and then I have a larger secondary flash that I can store all kinds of stuff on. But then I can keep on going down here, what's the level or the amplitude. And when you get into envelopes, that gets you into sound effects. And then I can go to these registers, and that gets me to those I/O ports if I want to use those. So that is, kind of what you're seeing in here. And if I collapse this out, let's see if there's anything else I want to point out. Those are probably the big things. This does have the underlying, bit banging to control those PSGs. So if you want to kind of see what that looks like, you could take a look through this. Again, I've got an older video that goes through all of that. So I would track that down, look for the link below if you want to watch that. So from my C shell down here, I'm making cop calls. From the cop calls, I'm making PIB calls over to the other board. That board then basically passes those through on down to sound.asm. And all of that is being done through an interrupt-based approach. So that then, got me to what you saw for the output. Going back over here, pulling up my VGA output. If I want, I could start something and then go into the Win app. Again, the audio is independent of everything else I'm doing here, unless I tell it to play something different. So I can come in here and say, play music. And I'll go back and play music 2. And you can see as I'm playing music, if I tell it to play something else, it instantly switches to it. But sound effects don't do that. They play on top of. But that just comes down to how I'm controlling the channels. And I have a lot I can do there to really make that better. But I have a good baseline now. So I know I can play 4-channel music plus 2-channel sound effects. I can do all that interrupt driven, let my secondary board continue to do other things like all of the video graphics management. And all of that can be done, disconnected essentially or asynchronously from my main board, because I can make a call, tell it to do all the audio, and then I can come back, do some processing for graphics, and then make those calls to actually draw, the primitives with the VGA circuit. And the system's been good and stable. Maybe just in closing here, you probably do know some things from the last video that have changed. I did get rid of that little, I had a little daughter board on here with the ability to add a couple of vias, and that was going to be for my mouse and my game controller here. And in the end, I just decided it was simpler to go without those vias and bring all of these lines for the PS2 and the gamepad into pins on this port B of this via up here, or this right port. Maybe that's port A, whichever. But this port is now doing all the mouse. It's doing the game controller, and I've got a few pins open that I can do other things with. But the mouse, I'm just plugging in here down to the side. I put a little cable adapter that goes from pin header to a plug-in. And I put the appropriate inline resistors and pull-up resistors all as part of that little cable assembly. And that's working great. This doesn't really require any pull-ups or inline resistors, or I don't have any on there. Maybe I should probably put inlines in there, but I didn't. But that's all going here. You might notice on a couple of these headers, I've got some little vertical resistors. I've been kind of tuning the clock. So on the Phi 2 down here, it goes all over the board. Same with the top one. And on this pin header, Phi 2 is one of the pins. And I've been kind of playing with a pull up or a pull down on that Phi 2, because it's kind of at the end of the Phi 2 chain on this board, and same with this board. And I'm finding that it actually helps kind of clean up that Phi 2 a little bit. So those for now I just have sitting there until I adjust other things. We'll see what I can do with the audio and graphics in the future. So I think if I think about, if I want to put a game together at some point, I've got controller working, I have the video working, I have the audio working for both music and sound effects. I've got sprites with transparency working. So really I think I have all the pieces that I can now start to build a game. Now I think building a game is a tremendous amount of work. I know I've seen people take a year or more to build, a basic type of game. I don't have the energy for that, but I'll probably tinker around with trying to do some game-like development and see what I can do. Maybe at least get Mario working with a small screen or two and jumping around, shoot things, whatever it might be, or some other shooter type of app. But I'm happy that all that stuff's coming together. It seems like I could feasibly build a game and have it, work in a decent way, perform in a decent way. Far from perfect, but I am learning a lot through this, so this is enjoyable. Hoping you're also enjoying this, and that's it for this video. So thanks for following here.